Hello everyone, today let us discuss about PN junction diode VI characteristics. Okay, this is one of the most important topics. It is also useful for your lab exam. Okay, let's start. So, the circuit diagram to study the VI characteristics is shown here. You can see here, this is the PN junction diode. P is connected to the positive terminal of the battery, N is connected to the negative terminal of the battery through a milliammeter and a switch. As already I told you in my previous video, in the forward bias current is of the order of milliamps. So we connected a milliammeter here. To measure the voltage across the diode, we connected a voltmeter here. Now, the circuit arrangement for studying the VI characteristics of a diode are shown in the figure. The battery is connected to the diode through a potentiometer or rheostat so that the applied voltage to the diode can be changed. Here you can see a variable symbol. So this is the symbol, one arrow across the battery shows it is the battery with variable voltage. So to vary the voltage you can connect a rheostat or you can connect through a potentiometer. For different values of voltages, the value of the current is noted. You have to make a tabular column. So you have to make a tabular column like this, V versus I. So for every value of V, you have to note the current I. And finally, you have to plot the graph as shown here. So this is the graph that is in the forward bias. Here on x-axis you have taken the voltage, on y-axis we have taken the current that is in milliamps. Voltage is of the order of 0.2, 0.4, 0.6, 0.8 etc. Very clearly you can see up to 0.6 there is no increase in the current. At 0.6 the current increases from here. You can see this is the graph in the forward bias. For different values of voltages, the value of the current is noted. A graph between V and I is obtained as shown in the figure. In the forward bias, we use a milliammeter and in the reverse bias, we use a microammeter. So now this is the circuit for the reverse bias. Now you can see P is connected to the negative terminal of the battery, N is connected to the positive terminal of the battery through a microammeter and a switch. Very clearly you can see, because in the reverse bias the current is of the order of microamps, which I already told you in my previous video. And to measure the voltage across the PN junction, a voltmeter is connected across the diode like this. Now in forward bias, the current first increases very slowly, almost negligibly, till the voltage across the diode crosses a certain value. That is what I have shown you. After the characteristic voltage, the diode current increases significantly even for a very small increase in the diode bias voltage. This is approximately 0.2 for germanium diode and 0.7 for silicon diode. For the diode in the reverse bias, the current is very small and almost remains constant with a change in bias. It is called a reverse saturation current. However, for special cases, at a very high reverse bias called breakdown voltage, the current suddenly increases. I'll take you back to this figure again. So this is what they told in the forward bias. So here it is the reverse bias. Till around 80, between 90, there is no increase in the current in the reverse bias. It's almost a straight line parallel to the x-axis. That means there is no increase in the current. But at particular voltage, you can see between 80 and 100, you can see here it is VBR, which is breakdown voltage. At breakdown voltage, suddenly current shoots up. So that is what they said here. However, for special cases at very high reverse bias called breakdown voltage, the current suddenly increases. The general purpose diodes are not used beyond the reverse saturation current region. The dynamic resistance of the diode is defined as the ratio of small change in voltage delta V to small change in current delta I. RD is equal to delta V divided by delta I. That means you can take the slope of the graph. Once you take the slope of the graph, it becomes that the slope of the graph will become delta I divided by delta V. But we want delta V divided by delta I, which is the resistance. So you can take 1 by M, where M is the slope, as the resistance of the diode. So once you take the slope and make it a reciprocal, you will get the resistance of the diode. So this is all about PN junction, forward bias and reverse bias circuit diagrams and the graph. Okay, so finally you need to calculate RD, that is the resistance, dynamic resistance of the diode, that is delta V divided by delta I. Okay, thanks for watching. God bless you all and grant you all great success in the coming exams. Okay, we'll meet with another topic in the next video. Bye.